Parts A through F ask you to decide whether this is a rational or irrational expression. So if you guys remember, rational and irrational numbers are opposites. Rational numbers are all fractions, as long as the numerator and denominator are not a root. All whole numbers, all integers. Irrational numbers are all roots that are not perfect squares, and numbers like pi and Euler's number e, because it goes on forever without a pattern. And the easiest way to think of these is if you don't have a root left after you simplify, it's rational, and if you're left with a root, then it's irrational. So for part A, square root of 28, is this going to simplify as a whole number? Well, nope, because 28 is not a perfect square. So we're left with a root, so this is irrational. Part B, two fractions that we're subtracting. There's no roots in sight. Fractions, every single one of them, as long as the root is not in the numerator or denominator, are rational. So part B is rational. Part C, we actually need to simplify this because possibly these roots, when you simplify, could be a perfect square. Because they're both roots, I can actually divide by a common factor of 5. So I'm only modifying the inside number, so the roots do not disappear. So 45 divided by 5 is 9, 5 divided by 5 is 1. And now we have a perfect square root, because square root of 9 is 3, and square root of 1 is 1. 3 over 1 is just 3. No root in sight, so we've got rational. 3 is a whole number. Part D, square root of 121 is 11, so this is 3 minus 11. No root in sight, which is negative 8. So we've got rational. Okay, part E and F, you might have to do a little bit of work. You're going to be multiplying two fractions. Again, you need to actually condense this as one possible expression because we need to decide whether the root disappears or not. So, one thing I can do, did I write this wrong? 3 over 3? I didn't write it wrong. 3 over 3 reduces as just 1, so I could cross that out. And then if I multiply straight across, root 2 times root 5, open up one root symbol, 2 times 5 is 10. And then the denominator is just 16. Well, 10 is not a perfect square. You're left with a root, so this is irrational. Last one, put a 1 under the first term in order to make it a fraction. So you can multiply straight across here. You could simplify 3/12 first. Divide by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So when I multiply straight across, I multiply the whole numbers first. 5 times 1 is 5. And then to multiply the roots, you open one root symbol and you write the product of 2 times 8, which is 16 on the inside. And that's all over 4. Square root of 16 is actually 4, so this is 5 times 4 over 4. 4 divided by 4 crosses out because that's just 1, so you're left with just 5. So this would be rational. There's no root. 5 is a whole number.